Right, we're going to look here now at the parabola as a locus, or not even as a locus, just going to look at the parabola here. Now we see we have this parabola drawn out here in SolidWorks, and there's three main parts to it here. As we have this fixed line along here, we have the center point of the parabola, which is the vertex of the curve, is the vertex of the parabola. And we also have this point here, and this is the focal point of the parabola. So if I draw any line parallel to this line here from our fixed line, so if I draw this line, another parallel line like this, out from here till it hits this curve, till it hits our parabola, like, and draw that straight back to our focal point, those two lines will be the exact same length. And just to show it here, I already have this one drawn out. I can follow this up and down with the trace. Look, it's totally dynamic. It can move completely, right? So I'll just use smart dimension here first to show you. That one is 103.1, and this one is 103.1. And to further prove it, we can draw a circle out. We'll draw a radius circle, measure the radius, like, go to that point there where it touches the fixed line, and as we can see here, that this point where we drew from here, this will be our locus, because the parabola is also another example of a locus being plotted along within some fixed parameters, such as like focal points. But we drew from this point. This is our center of this circle, and it's out to this line. And if we look, it actually passes through our focal point as well. So even as I move this, we can see the radius. We can see the whole circle getting smaller in proportion with the lines. And we didn't even have to draw this circle, to be honest, because there's this circle already here, and we can already see that this distance is the same as this distance, because from a center point, the two radii are the same length. Any distance from center out to the circumference of a circle are all the same length. So we have that there, and I'll just talk about it as a locus now. Like, as a locus, the parabola is another good example, like an ellipse, because it has a focal point, and we have this fixed line here, but we are plotting this line, or plotting this point along that line. So I'll just get rid of that there for a minute, so it's easier. It's not clogging it up as much, but we can see that our fixed parameters here, or our parameters here, for plotting the point are these two lines. That this line must always remain horizontal to this line, and it's able to vary in distance depending on how far up or down it's on this line, our fixed line here. So as we move this up and down, it remains the same. Or that line is still horizontal, as you can see by our because it says horizontal there, as you can see by our sketch relations, that is horizontal, as is this one. So then this line from the focal out to there is always going to be the same length as that, as we've just proven. So there you go. I think that's the parabola sort of described there now.